Hello and welcome to K2P classes. In this class we are going to study number line in number systems. Guru Bashisht says that success is proportional to effort given, dil se. In the previous class we have studied introduction to number system, irrational numbers, real numbers and their decimal extensions. Here we will read real number on the number line. What is a number line? A number line is an infinitely long line whose points match up with real number system. Let us take this as a number line. So we can plot any real number on this line. For example, 1, 2, 3, 4, 5, all the positive numbers are on the right hand sides. All the negative numbers are on the left hand side of 0. Suppose we want to plot 1.5. So 1.5 will be here. 5.25 it will be here. Right? Now we will see on a number line how we are going to plot a given real number.
We saw in the previous video, let's see how we plot the length root 2 on a number line. So let's plot it on this number line. We need to make a right triangle with one unit as the base. Let OA be the base of that triangle. We also want its height to be 1 unit long. Let's draw the height AB like this. We just drew AB equal to 1 unit perpendicular to OA. Both these length equal 1 unit. Now all we have to do is join OB like this. Let's analyze the figure. We have OA equal to 1 unit and AB equal to 1 unit. Using the Pythagoras theorem, we have OB squared equal to OA squared plus AB squared. That would equal 1 squared plus 1 squared, which is 2. Taking the square root on both sides, we get OB equal to root 2 units. This length here will be root 2 units. We just need this length here on the number line. To do that, we keep the vertex of the compass here and with length OB cut an arc on the number line. Let's call this point C. This green length OC will equal this length since they are the radii of the same circle. Hence length OC is also equal to root 2. And if we need minus root 2, then we cut the same arc on the other side of O. Let's quickly see how we can actually construct it. Let OA be 1 unit long. Then we take a protractor, make a 90-degree mark and join that point to A. Then on the compass, we take the length of 1 unit and mark it on this line to get AB as 1 unit. And then we join OB. This length OB is root 2 units. And that is the length we need on the number line. So we keep the compass on point O, take length OB and cut an arc like this. That gives us length OC as root 2 units.
Abhi, square root 3, how do we represent square root 3, which is again an irrational number on a number line. So यहाँ पे दोस्तों हमने पहले से ही एक unit square draw की हुई है on the point unit square ABCD on the number line. So अभी last example में हमने देखा कि ये जो length है applying Pythagoras theorem जो BD है that is square root 2, right? So अभी हम क्या करते हैं दोस्तों? Now we have to show square root 3, right? We have to find out square root 3. So first step what we do दोस्तों is that we go to point B, right? और यहाँ से हम 1 unit ऊपर we draw a line B from B 90 degree to BD. ये जो BD आपकी लाइन है जो डायगोनल है ऑफ द यूनिट स्क्वायर जिसकी लेंथ स्क्वायर रूट 2 है, BD से परपेंडिकुलर ड्रॉ करते हुए फ्रॉम पॉइंट बी हम एक 1 यूनिट लाइन ड्रॉ करते हैं लाइक दिस. उसके बाद दोस्तों व्हाट वी डू, वी जॉइन D एंड दिस पॉइंट. सो उसके बाद व्हाट वी डू इज वी जॉइन B द पॉइंट D एंड दिस पॉइंट. सो मान लीजिए इस पॉइंट को लेट अस कॉल इट एज Y. सो अगर हम इस पॉइंट को Y बोलते हैं दोस्तों, सो नाउ अगर आप नोटिस करोगे इन ट्राइंगल D विच इज D BY, इन ट्राइंगल D BY, अगेन पाइथागोरस थ्योरम अप्लाई करके यू कैन टेल दैट dy स्क्वायर इज इक्वल टू BY स्क्वायर प्लस जो dy है, दिस इज द ट्राइंगल DBY is a right angle triangle by design, by our construction, right? So Pythagoras theorem states the hypotenuse square, which is the dy square, will be altitude square or height square, which is by square, and the base square, which is bd square. bd square. Now by is by design 1 unit, 1 square, and जो bd है, bd, this we know is square root 2, that square. So this, on solving we get 1 plus 2, square root 2 is square root 2 into square root 2, square root 2 square is square root 2 into square root 2, which is 2. So we get dy square is 3, or in other words dy is square root 3. So ऐसे करके हमने प्रूफ किया कि ये जो लेंथ है आपकी dy, दिस लेंथ इज स्क्वायर रूट 3. अगेन दोस्तों हमें मालूम नहीं है कि स्क्वायर रूट 3 की वैल्यू कितनी है, बट वी फाउंड आउट दैट dy इज स्क्वायर रूट 3. सो अगेन टेकिंग द एग्जांपल ऑफ द कॉम्पस, कि कॉम्पस की जो पॉइंटेड एंड है, मान लीजिए दिस वन, एंड जिस एंड में आप पेंसिल डालते हो इफ इट इज दिस वन, सो आप पॉइंटेड एंड को यू पुट इट ऑन द ओरिजिन, राइट? Put the pointed end of the compass on the origin, and जो दूसरी end है जहाँ पे पेंसिल डालते हो उसको आप extend कीजिए to this much, and then वहां से आप जो pointed end है इसको आप origin में रखते हुए इस लेंथ से आप एक arc ऐसे करके draw कीजिए. So the arc will cut the number line on some point, let us call it x, and then जो आपकी length है OX या फिर DX, so ये जो dx लेंथ है आपकी, dx is equal to जो ox है, this is nothing but equal to dy. Why? Because it's a same radius में लेते हुए we have drawn an arc, right? Same radius dy and ox or dx, same radius है, and this is the arc, and dy we just saw square root 3. So इस तरह से we note that the length OX is square root 3. So ये पॉइंट आपकी बन गई नंबर लाइन में square root 3. So दोस्तों इस तरह से हमने देखा, we have taken 2 examples. एक में हमने देखा कि how we can get square root 2 on number line, and दूसरे में हमने देखा how we can get.
Now we will see how we can draw any root of any number, natural numbers, right? Root 1, root 2, root 3, root 4, root 5. So what we are doing, we have taken here as 1 and on y-axis 1. So naturally this will be a root 1, right? So if we draw like this, it will be a root 1, because we know that from the Pythagoras theorems that hypotenuse square equal to height square plus base square. So this will be a root 2. Now locate root 2 on the number line. So just with the radius of this, we draw a circle which cuts x-axis here. So this is root 2. Now let us go for root 3. If we had a right triangle with one leg root 2 and another root 1, the hypotenuse would be root 3. Why? 1 square plus root 2 whole square is root 3 plus 1. So here we know this is root 2. From here, or this is root 2, right? This line from here to here, we take another right angle triangle, and since this is root 2 and this is 1 by design, so this side hypotenuse will be root 2 square plus 1 square, means root 3. So this is also root 3 from any side, from right hand side or left hand side. Then taking this much as a radius, we will draw another circle which will cut number line at this point, and this is nothing but root 3. Similarly, if we have to draw root 4, so what we will do? We will take a rectangle like this, where it is root 3 and this is 1. So what will happen? The hypotenuse will be root 3 square plus 1 square root under, and that is nothing but root 4, and root 4 is 2, right? So if taking this red line as a radius, if we draw a arc, it will cut x-axis at point 2. So on that line, it will on the number line, this will be 2. Now if we have to find root 5, what we will do? We will make a rectangle here to this side. This, so this will be 2, this will be 1, or this will be 2, this will be 1. So 2 whole square plus 1 whole square, it will be 5 root. So this length will be root 5, O to this length. So taking this red line as radius, we will draw arc which will cut x-axis at this point, and it is root 5. Similarly, root 6, root 7 can be drawn. So in fact, we can draw a root of any natural number, positive natural number, in this fashion. So it is root 6. Now we can draw root 7 as well. How? Just take this line. This will be root 6 square plus 1 square root 7. So taking this red line, if we draw a arc, it will cut x-axis at the distance root 7. Similarly, root 8 can be drawn. So by this method, we can draw a root of any natural number. Here in this first slide, first video, we saw how we can draw root 2. In the second video, we see how we can draw root 3. Here we have seen how we can draw root of any natural number, positive natural number, 1, 2, 3, 4, 5.
In the video, we will learn how to plot root x. In the earlier part, we saw how we can plot root 2, but we did not know how to plot root 3.8. X can be any positive rational number. It can be an integer or maybe a decimal number or any of that sort, but has to be a positive rational number. Let this be our x-axis. We will try to plot root x here. Let's not mark the origin yet. We will just try to plot root x somewhere on this line. Before we plot root x, let us just plot x. Let AB be equal to x units. We mark AB on the axis. This distance is x units. This video is very interesting, but it's slightly lengthy. So please try to focus really well. Here's the first step. We produce AB to C such that BC is 1 unit. We just have to extend AB in this direction by 1 unit. So we mark point C here such that this length is 1 unit. This length is x units and this length is 1 unit. So this total length AC will equal x plus 1 units. We just produced AB to point C such that BC is 1 unit. In the next step, we just bisect AC at point D. It means we divide AC into 2 equal parts and name the center point D. So AD will equal DC. Let's review what we just did. We had to plot root x. We took AB equal to x units on the axis, extended it by 1 unit to form AC, and then we divided AC into 2 equal parts at point D. So if AC is equal to x plus 1, then AD and DC will equal x plus 1 divided by 2. In the next step, with center D, we draw a semicircle above the line. If D is the center, then the endpoints of the semicircle will meet points A and C. The semicircle will look something like this. DA and DC are the radii of this semicircle. Then we come to the final step. We draw a segment from point B to this semicircle such that it is perpendicular to AC. Let's assume the segment meets the semicircle at point E. So we draw BE perpendicular to AC, like this. That's it. We are done. This length will equal root x. Length of segment BE will equal root x. Once we know that this length is root x, we can just keep the vertex of the compass here and mark root x on the x-axis. So these were the steps we followed to plot root x on the number line. But wait, how do we get BE as root x? There's nothing obvious in this figure. So let's prove this fact. Let's prove why BE will be root x. The length AC, as we can see, is equal to AB plus BC, which is x plus 1 units. So we have AC is equal to x plus 1 units. To complete the proof, we need to do a little bit of construction. We need to join DE like this. What do you think will be the length of DE? It's simple. It will be the length as AD or AC, as they are all radii of the circle with center D. And we know that since D is the center of AC, AD will equal DC will equal half AC. So DE will also equal half AC. Since AC is x plus 1, DE will equal half multiplied by x plus 1. Now observe this triangle. Triangle DEB. We know the length of the hypotenuse. If we find the length of DB in terms of x, then by using Pythagoras theorem, we can find the length of BE in terms of x. The length of DB will be equal to this length, which is length of DC, minus this length, which is length of BC. The proof is a little long, so let's zoom out a bit. We can say that DB is equal to DC minus BC. We know that length of DC is equal to the length of DE, which equals x plus 1 by 2. And length of BC is equal to 1 unit. Solving this, we get length of DB equal to x minus 1 by 2. So we have the lengths of DE and DB. By the Pythagoras theorem, this squared will equal this squared plus this squared. Hence BE squared will equal DE squared minus DB squared. DE is equal to x plus 1 by 2. DE squared will equal x plus 1 by 2, the whole square. And DB is x minus 1 by 2. DB squared will equal x minus 1 by 2, the whole square. All we need to do is solve this to get BE. Since both are squared, we will get a 4 common in both the denominators. So let's separate 1 by 4 from both the terms. X plus 1 the whole squared will equal x squared plus 2x plus 1, and x minus 1 the whole squared equals x squared minus 2x plus 1. Opening up the brackets, we get this expression as 1 by 4 multiplied by x squared minus x squared plus 2x plus 1 minus 1. These two terms and these two terms cancel out, and this expression equals 4x by 4, which equals x. Since BE squared is equal to x, BE will equal root x units. The proof is long, but is very straightforward. The construction is simple, the steps are simple, and to prove it, all we need to do is focus on the triangle. Once we know that BE is root x units, all we need to do is keep the vertex of the compass on point B and mark an arc like this to cut the x-axis at point F. Length of BF will also be root x units. So if we want to find the square root of 3.8, all we have to do is take AB as 3.8 units. You will get BF equal to root of 3.8 units. To understand the detailed explanation, please watch the third part of the video.
So in this way, we have learned how to draw a root x where x is any real number, positive real number, on number line. So in this class, we have done. In next class, we will learn more thing about real numbers. So thank you very much.